majority of the quiz tomorrow will be on factoring and using factoring to solve quadratics also, all right? So when we have a quadratic equation, we factor and then we split it using the zero product property, then we solve. But there is going to be 4 questions and only 4 questions that are going to be selected from this little mini lesson on simplifying radicals. Okay, so let's begin this together. It says make a perfect square number list from 1 to 144. So I hope we all know that 1 would be the first one, the next one would be 4, the one after that would be 9, and then after that, what's the next number? Perfect square number? 16. After that, 25. After that, 36. And then 49, 64, 81, 100, 121, 144, and this continues on forever. Now, if you're thinking, where the heck did these numbers come from? They simply came from taking the number 1 and squaring it. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on, right? So we need to know that these numbers are called perfect square numbers, all right? Now, here's a fact. The square root of a perfect square number is a perfect answer. It's a nice, beautiful answer. When you take the square root of 9, that's 3. When you take the square root of 64, that's 8. The square root of 81, that's 9. The square root of 1 is 1. The square root of 144 is 12, right? The square root of 16 is 4. The square root of 81 is 9. The square root of 121 is 11, right? So taking the square root of a perfect square number is beautiful. We want to take the square root of a perfect square number all the time, right? Here's a fact. If you have the square root of 2 numbers that are being multiplied together, you could actually take that square root and split them into each, the square root of A and the square root of B. So for example, if you have the square root of 18, you could rewrite 18 as 9 times 2 and then split the root to each of those, and then you could actually do the square root of 9. So the idea is this, guys. We would love this to be a perfect square number, right? We would love this to be a 25 or a 16 or a 9, but it's not a perfect square number. So what we do is we rewrite this with multiplication to actually get a perfect square number. That way we could split them and then actually do the square root of 9. This is what we call simplifying radicals. But this rule of splitting radicals also works backwards. You could have 2 separate square roots that are being multiplied together, and you could actually put them both together underneath one square root and multiply the terms. An example of this would be the square root of 8 times the square root of 2. You could put those together as 8 times 2. That way you'll get 16, and you could actually do the square root of 16 because that's a perfect square number, giving you a perfect answer 4. Now the rules are the same for division, just like multiplication. You could actually split them or put them back together. So if you ever have the square root of something over something, which is really something divided by something, you could do the square root of the top over the square root of the bottom and get your 2 answers that way. An example, the square root of 9 over 25 is really the square root of 9 over the square root of 25. You split the root. Square root of 9 is 3. Square root of 25 is 5. Answer is 3/5. Okay. Or you could have them separate and you could put them together. The square root of 8 over the square root of 2, you could put them together as a square root of 8 over 2. And 8 over 2 is 4, and the square root of 4 is a nice perfect answer 2. So you could use these rules forward or backwards. You could split them or put them back together, whatever benefits you, right? Now, how to simplify radicals. Again, let me repeat, I already mentioned this. If you don't have a perfect square number, break it down with multiplication to get a perfect square number, all right? So the square root of 20 is not a perfect square number. 25 would be, 16 would be, but 20 is not. So we do not like the square root of 20. If you do the square root of 20 on a calculator, you get an irrational decimal. It's crazy long decimal. So we want a perfect square number, so we're going to rewrite it with multiplication. So would I rewrite this as 2 times 10? Heck no. Why not? Because 2 is not a perfect square, 10 is not a perfect square, but 4 is a perfect square. So it's really nice to have these numbers up here written down on your paper so you could see where the perfect square numbers are and see which one of these numbers you could actually rewrite your number as. So the square root of 20, you're going to rewrite it as the 4 times 5, because 4 is a perfect square number, and when you split them, you'll be able to do the square root of 4, which gives you 2. I'm rushing through this, I apologize, but then again, you're supposed to know this from Algebra 1. Yeah? No? Oh gosh. Okay, well some of us do know it, some of us don't. How about this? You don't need to be a pro at this per se, because the Casio calculators do this for you. Okay, so you could actually type in the square root of 50 on the Casio calculator, and it'll give you 5 square root of 2 as your answer. But you need to be able to show your work, all right? So let's say the square root of 50, that's not a perfect square number, right? Okay, so let's rewrite it with multiplication. Would you rewrite it as 5 times 10? No, why not? Because 5 is not up here on this list. 10's not up here on this list. So I want to break down 50 to one of these numbers. Could I do it with 4? No. Could I do it with 9? No. 16? No. 25? Yes. Right? So that's why this list is great to have. So let's rewrite the square root of 50 as that 25 times 2. Some of us say 2 times 25, but it's better to go the perfect square number first, because that's what we want after all. So when we split it, you'll actually be able to do the square root of 25, which is what? 5. So you have 5 square root of 2. And that's it. Now, of course, on the Casio calculator, if you type this in, it will give you this answer. But I want you to understand how to rewrite it with multiplication and how to split it, okay? So how about number 2? 72. Well, I could break this down to, like, I want a perfect square number, right? 72 is not a perfect square number. It would be nice if this 72 was a 81. It'd be nice if this 72 was 64, right? But it's not. 72, it's not a perfect square number. So I want to rewrite it with multiplication to get a perfect square number. I could do 9 times 8, but that's not my best option, right? If I go, let me show you. If I go 9 times 8 and you split it, you'll get the square root, or the square root of 9, which is 3, and the square root of 8, which could still be broken down further. So the square root of 8 could still be broken down to 4 times 2, and then you'd have to split the root again. And then you'd get 2 square root of 2. But don't forget about the 3 that's up here. So you'd really have 3 times 2 times the square root of 2, which is really 6 square root of 2. Now that's pretty ugly. But if we take a couple of seconds and look at our perfect square number list and think, which of these numbers could I rewrite 72 as? You'd be like, okay, 4, yeah, 9, yeah, but maybe 16, 25. But 36 is the biggest perfect square number that I could rewrite that as. So I could rewrite 72 as 36 times 2. So imagine that. If I just rewrote it as 36 times 2 and then split the root, I'd get directly to my answer. The answer is 6 square root of 2. Got it? Yeah. Okay, so I hope we understand this. How about that square root? Actually, I'll let you guys do that one. Square root of 27. So your homework for tonight is to study for the quiz and also finish this worksheet. These are pretty easy. What's the answer to number 4? 2/3, because when you split it, you get 2 up on top, 3 on the bottom. You guys could do number 5. Let's jump to number 6. A lot of people are going to jump right into this and split the square root to the 28 and to the 7, and then have a lot of work to do. What's the easiest, quickest path to this answer? Just divide it. 28 divided by 7 is what? 4. So you really have the square root of 4. Well, that's a perfect square number. So what's the answer? 2. Done. Easy peasy, right? Okay. Let's actually do 7 because it doesn't work out that nice. 8 is not divisible by 25. You can't reduce that fraction either. So we will have to split the square root to the 8 and to the 25. Now, which one of these is easy to do, the 8 or the 25? 25. All right, so what do I get when I do the square root of 25? I get 5, right? That's what I have on the bottom. Now the square root of 8 up on top, let me do that right here on the side. The square root of 8, that's not a perfect square number, but I could rewrite it as what? 4 times 2. So when I split the root, I actually will get 2 square root of 2, correct? So rewriting the square root of 8 to 2 square root of 2, that's what we need to do. The square root of 8 becomes 2 square root of 2, and that's it. That's your final simplified answer. Will that one be on the quiz tomorrow? Definitely not. But it's still important to know. We're going to have to know it in the future. All right. Here's another important fact, and this fact will be on the quiz tomorrow. The square root is really the power of 1/2. Okay, we need to know this. The square root is really the power of 1/2. Okay. In other words, when you have the square root of x to any even exponent, you simply divide the exponent by 2. Now that might not make too much sense right now, but it will after a couple of examples. Like this guy right here, we just said that the square root is really the same thing as the power of 1/2, right? What do I have on the inside of the parentheses? I have x to the 6th. So when I have a power to a power, what am I supposed to do with those powers? multiply them, right? Power to a power, you multiply. You guys remember that from Algebra 1? Okay, so what's 6 times half? 3. So what's your answer going to be? X to the third. So what I explained above is that if you have the square root of x to any even power, you really just divided that power by 2. Does that make sense? All right, so how about number 2? What's the answer going to be to number 2 if you understand that? 3 to the first, or just 3, right? Another truth that we should already know is that a square root is the opposite of a square, and they kind of undo each other, which is why the answer is just 3. I mean, you could say 3 to the first, but 3 to the first is just 3, right? How about that one? 2 to the third power, right? And what is 2 to the third power? 8. So the final answer would be 8 right here, okay? Yeah, if you actually could do 2 to the third, you might as well do it. 2 times 2 times 2 is 8, right? What if you don't? Then I'll give you half credit, right? I mean, math class, you want to be able to do the math, especially the easy math, right? Now, again, the explanation here is that the square root is really the power of 1/2. So you really have 2 to the 6th, power to a power you multiply, so you have 2 to the third, and we could actually do 2 times 2 times 2, which is 8. Okay? This one, you're definitely going to see one of these on the quiz tomorrow. The square root of x to the third. Now, we want a perfect square term in here, right? We want an even power up here, okay? So just like before, check this out. Up here, right here, when I did the square root of 8, this was not a perfect square number. What did I do? I rewrote it with multiplication to get a perfect square number, right? So down here, we're going to do the same thing. We're going to use multiplication to get what we want. See, we would want an even power right here, right? So I'm going to rewrite this whole thing with multiplication to get something with an even power. So I'm going to rewrite the x to the third as x squared times x. And yeah, I still have the square root on both of them, but I'm going to split the square root, the square root of x squared times the square root of x. And the square root of x squared is x, and the square root of x has to stay the square root of x. So this is your final simplified answer. It's pretty easy to understand, but there is bad news about this. The calculator can't do this one because you can't type in a variable button. There is no variable button x. So you're going to have to actually understand this and be able to do this on the quiz tomorrow. We have a lot of practice over here. I'm not going to do all of them. I'm just going to jump through a couple of them. So isn't number 7 easy? What's the answer to number 7? X to the third. That's your answer. Of course, the correct work would be to show the power of 1/2, show that x to the 6th in there, and then 6 times 1/2 is x to the third, right? Half of 6 is 3. So the answer is x to the third. But you will have one like this as well. So again, this one is just like the other one. What would I do? I want to rewrite it with multiplication to get what? What would you like to have in here? Not a 7. You'd like to have an even power. Yeah, so you could divide it by 2, right? So you don't want a 7. You'd like an 8 or a 6. So it's easy to rewrite it to get the 6. All you have to do is say x to the 6 times x to the 1. And then you split it. And you should get, what's your final answer? X to the third square root of x. If you don't understand that, you need to understand it, or else you're going to miss one on the quiz tomorrow. It's on there for sure. Maybe that exact one. You guys could try number 9. I'm pretty sure you could get it. Once you understand it, you'll be able to even look at this and know the answer is going to be x to the 8th times the square root of x, right? Once you get it. Let's do a couple more. Number 14. Again, the Casio could do this for you, but it's still important to know how to do. The square root of 12 is what? You need to break it down with multiplication, don't you? It's not a perfect square number. So you're going to have 4 times 3. You're going to split that root. And what's the square root of 4? So you really have 2 square root of 3 with this 3 out in front. Now what's happening with that 3 out in front? You really have 3 times the square root of 12. So right here, the multiplication of 3 comes down as well. And you could multiply 3 times 2. What is 3 times 2? 6. So your final answer would be 6 square root of 3. 6 square root of 3. So let's understand this. Right here it says 3 times 2, and it really has a times right there. And you could multiply the numbers, but you can't actually multiply numbers with radicals. So you would just leave it. 3 times 2 is 6, and that's really saying 6 times the square root of 3. You don't mess with these guys. That's as far as it goes. This one's a little fun. We could just rearrange it since we're multiplying everything. Right? There's commutative property in multiplication. 3 times 2 is the same thing as 2 times 3. So we could rearrange this and say 3 times 4 times the square root of 2 times the square root of 8. And we could say 3 times 4 is 12. Square root of 2 times square root of 8, you could actually put that together to give you the square root of 2 times 8, which is the square root of 16. So you really have 12 times the square root of 16. That's really 12 times what? 4. And the square, and 12 times 4 is 48. No more square roots. Fact: when you apply a square root when solving an equation, you must put a plus or minus symbol in front of your answer. Okay, so we're definitely going to need to know this on the quiz tomorrow. Practice solving quadratics. It's really easy to get rid of a square. You do the opposite, which is a square root. But whenever you apply a square root, what you do to one side, you do to the other, and you must put a plus or minus in front of your answer. So your answer is x equals plus or minus 3. And that makes total sense because a positive 3 will work, right? Positive 3 squared is 9, and also a negative 3 in parentheses squared will work. It'll give you a positive 9. So you actually have two answers, positive 3 and negative 3. If you just put x equals 3, you only get half credit because you only gave me half of the answers. Let's take a look at number 2 over here. What would you do to get x squared by itself? Add 16, divide by 4, and then square root the whole thing, right? And put a plus or minus in front of your answer. I think you guys can handle that. Let me jump to something a little more challenging, maybe like 4 or 5. Sure, why not? Let's do 4. So right here on number 4, let's subtract 10. Subtract 10. We're going to rewrite this thing. We're going to have 3 parentheses x plus 1 squared equals 27. And then what? You could, well, see, you can't really distribute because there's an exponent on the binomial, right? So yeah, let's get rid of the 3 by dividing by 3. Dividing by 3, we'll have a new equation that reads x plus 1 squared equals 9. That looks nice. Why? Because you could actually get rid of that square by applying a square root. And whatever you do to one side, you must do to the other. But remember, when you apply a square root in an equation, you have to put a plus or minus in front of your answer. So what we have so far is x plus 1. Actually, I don't even need these parentheses anymore because the square is gone. I just have x plus 1 equals 3. But I need to put a plus or minus right in front of my answer. I need one more step. What is that other step to get x by itself?
Subtract 1.
Subtract 1. Subtract 1. Now this is kind of weird because you have a positive 3 and a negative 3. So it's kind of weird to subtract 1 from a positive 3 and a negative 3. You actually have to do both. So let me explain what you should do. First of all, this x is now by itself. I would rewrite this guy exactly the way it is, but with the negative 1 first. Negative 1, and then the plus or minus 3 second. And then actually do both cases. Do the negative 1 plus 3, and then do the negative 1 minus 3. That's what it means. Plus or minus means that you're going to do both. And right here, because you could actually do both, you do both. Negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And those are your two answers to this quadratic equation. 2 and negative 4. On your answer sheet, you should put x equals 2 and negative 4. Or you could put x equals 2, x equals negative 4. Don't write it as a coordinate, right? We don't have x and y values here. It's just two answers. X equals 2, x equals negative 4. What do you guys think? Let's take a look at this last one, probably the hardest one. Expect it to be on the quiz tomorrow. Maybe the same exact one. Subtract 10, subtract 10. Let's rewrite this guy. It's 2 parentheses x plus 1 squared equals 64. Divide both sides by 2. We're going to end up with x plus 1 squared equals 32.
So minus 199.
We're going to have to square root. So what do I have left here? I have x plus 1, no more square root, no more parentheses, no more square, equals, I must put a plus or minus in front of my square root of 32. However, the square root of 32 is not a nice answer. So we need to take this square root of 32 and simplify it over here on the side. 32 could be broken down to 4 times 8, but what's a better perfect square number to break it down by? 16 times 2, thank you very much. That way when we split the root, the square root of 16 is 4, and the square root of 2 is going to stay the square root of 2. So what do I have here? I have x plus 1 equals plus or minus 4 square root of 2. We still need to get rid of that 1, so we're going to subtract 1, cancels out. Let's rewrite it. X equals, I always say just rewrite the whole thing, but put that negative 1 first. Negative 1 plus or minus 4 square root of 2. Now at this point, I am not going to go any further. Why? Because I can't really add a negative 1 to a radical, and I can't go minus 1 minus a radical either. The only way you could add is if you actually had 2 radicals, or if you actually had 2 numbers. So right here, you leave it, that's your answer. Up here, we actually went through and did the plus and the minus because we had 2 numbers. We could actually do negative 1 plus 3 and negative 1 minus 3. That's why we got 2 separate answers. I did not stop right here at x equals negative 1 plus or minus 3 because you could actually do that. But down here, when you get to the x equals negative 1 plus or minus a radical, you cannot add or subtract radicals. It's like they're different terms. You need like terms to be able to combine. Anyways, that's the end of these notes right here. These are pre-notes to 4.4, which is what we're going to be doing on Monday. But I will put 4 of these questions on the quiz tomorrow, just 4. Okay? One of them you'll be able to do on a calculator. The other one's going to be something like this guy, the square root of x to the 7th. You can't do that on a calculator, right? And we're probably going to have maybe 1 or 2 of these equations that we just did. Okay? So only 4 of the 20 come from this worksheet. The rest of the quiz is all about factoring, and factoring to be able to split and solve when you have equations. So let's, I want to create another video covering a review for the quiz. Please finish this. The answers are on the back if you need them.